Stoichiometry, relating amounts of chemicals to each other. The cardinal rule is that in order to relate one chemical to another, it has to be done on a mole-to-mole basis using a balanced chemical equation. That's depicted here in this cartoon. Now, there are different ways to get to moles. These are just illustrating two of the ways to get to the moles of something. But at its core, every stoichiometry problem is a mole-to-mole ratio using a balanced chemical equation. Here is a simple stoichiometry problem. We're given a balanced chemical equation. We could check, but we have the same number and type of atoms on the reactant side as we have in the products. The question is, how many moles of nitrogen gas are required to completely react some amount of oxygen? So we're relating one chemical to another, and we're going to use a balanced chemical equation. This is what we mean when we say we can use the chemical equation as a conversion factor. Our balanced chemical equation tells us reacting 2 moles of N2 is essentially equivalent to saying we reacted 3 moles of oxygen. So we have an identity, and based on this identity, we can write 2 different conversion factors. They have equivalent quantities in both the top and the bottom. The version of the conversion factor we use depends on the units we're given and where we want to get to. So we rewrite the number, the measured number we're given with its unit, and where we want to go. We want to cancel out moles of O2 and end up with moles of N2. So we need to choose the version of the conversion factor that has moles of O2 in the denominator and N2 in the numerator. Our conversion factor tells us that reacting 3 moles of O2 is equivalent to reacting 2 moles of N2. So when we look at our units, we see our units of moles of O2 cancel out. So the units that survive in our answer are moles of N2. We can do the math. So it's 0.460 times 2 divided by 3. So we get our calculator answer. Now we can go back and look at our sig figs. Our first number here, 0.460, has 3 sig figs. Our mole-to-mole conversion factor is exact, which essentially means it has an infinite number of sig figs, or in other words, it does not affect the sig figs in the answer. So we have three sig figs in our answer. The first number we drop is greater than 5, so we add 1 to the preceding column. Our final answer is 0.307 moles of N2. Our balanced chemical equation can be used to relate any chemical to any other chemical that's also in that equation. So in this next question, we're attempting to relate moles of N2O3 to moles of O2. We write our measured number that we're given along with its units, and we're going to multiply it by some conversion factor we get from the balanced chemical equation to get to moles of N2O3. So if we look at our balanced chemical equation, we see the coefficient associated with oxygen is 3. So in the denominator, we write 3 moles of O2. The coefficient associated with our product, N2O3, is 2. So in the numerator, we write 2 moles of N2O3. Okay, what this is saying is that reacting 3 moles of O2 is essentially equivalent to producing 2 moles of N2O3. and we set up our conversion factor so that the units of moles O2 cancel out, and the unit that survives is N2O3. Now we simply do the math. So we multiply 0.460 times 2, divide that by 3 to get our calculator result. We look to sig figs. This number has 3 sig figs. This is an exact number, so it has an infinite number of sig figs, will not affect the sig figs in our answer. So we have 3 sig figs that are justified in our final answer. So our final answer is 0.307 moles. And we can continue on and use this balanced chemical equation to relate any chemical to any other chemical. In your notes are more problems associated with 2 other balanced chemical equations. You do them the same way. You start with a balanced chemical equation and write an appropriate mole-to-mole conversion factor. Do the multiplication, get your calculator answer, go back and write your answer with the appropriate sig figs.